Objective, converting decimals to fractions. We need to start with some definitions. Definition number 1, a fraction, a number in the form a divided by b, where b is not equal to 0. We cannot have 0 in the denominator of a fraction at all. Definition number 2, decimal, another form of a fraction whose denominator is a power of 10 and the numerator is written as digits to the right of the decimal point. So we have decimal places, tenths, hundredths, thousandths, and that's where this comes from, powers of 10. Definition number 3, convert. This just means to change the form, whether it's from a decimal to a fraction to a decimal to a percent. To convert means to change the form. Definition number 4, repeating decimal. A decimal in which a digit or a sequence of digits repeats itself indefinitely. So we have repeating decimals and then non-repeating decimals. Non-repeating means it doesn't repeat. Definition number 5, terminating decimal. A decimal which can be expressed as a finite number of figures or all figures to the right of some place are 0. We know that if we stick zeros on the end of any number after the decimal point, then it doesn't change the place value. So we have a terminating decimal, terminating like a terminating illness. It means the decimal stops. Just like a terminating illness, it kills you. So we have terminating decimals, and then non-terminating decimals are like pi, where it continues on and on forever. Vic number 1. A line over a digit or a sequence of digits is used to indicate a repeating pattern. So we have a bar, that line we call it a bar, a repeating bar. So 0.7 with a bar over the 7 means the 7 repeats. And these 3 dots are called an ellipse. It just means it continues on, 7, 7, 7, 7, 7, 7, forever. Example number 2, 3.42, and the 4 and the 2 are both under the bar, which means that pattern repeats, 4, 2, 4, 2, 4, 2. Now the 3 is a whole number, and it's not under the bar, and it's the whole number part, so the 3 stays the same. Vic number 2, to convert a non-repeating terminating decimal to a fraction. So this is just a regular decimal like 0.17. It doesn't repeat, and it stops. After that 7, there's just a bunch of zeros, it stops. So here's the process. You're going to drop the decimal and write the number in the numerator. Put a 1 in the denominator, and then add zeros to the denominator until the denominator is larger than the numerator. Then reduce to lowest terms, and you can use your calculator for the 4th step. Converting terminating decimals to fractions. So let's put those 4 steps to practice. Example number 3, 0.019 or 19 hundredths. So we just drop the decimal, so 19 goes in the numerator, put a 1 in the denominator, and then add zeros until the denominator is bigger than the numerator. So 10, not bigger than 19. 100 is bigger than 19. And 19 divided by 100, you cannot reduce this fraction any further. So 19 hundredths means 19 over 100, 19 parts out of 100. Example number 4, 583 thousandths. So 583 goes in the numerator, just ignore the decimal. Put a 1 in the denominator and add zeros until the denominator is bigger than the numerator. So 10 is not bigger than 583, 100 is not bigger than 583, 1000 is bigger than 583. Now we need to check to make sure that it's in lowest terms. So you can type in your calculator 583 divided by 100, because that fraction bar means divide, and then press math, enter. So math, and then hit enter twice. And in this case, it gives you back the same fraction that you started with. So this one is in lowest terms already. 62 hundredths. So we can say 62 goes in the top, put a 1 in the bottom, and add zeros until the bottom is bigger than the top. So 100's in the bottom. 62 divided by 100. Type this into your calculator. Press math and hit enter twice. And your calculator is going to change it to lowest terms, which gives you 31 over 50. So this would be your answer. 62 hundredths is the same thing as 31 over 50. Now, you could have done this without a calculator. 62 divided by 2 is 31, and 100 divided by 2 is 50. So just reduce the fraction. Now, this one's different than the others because it has a whole number part. The whole number part is 4, and we're going to have to convert that at the end. So let's look at just the decimal part, 9/10. So 9, put a 1 in the bottom, and then add zeros until the bottom's bigger. So now I have 9/10. Well, this is 4 and 9/10. I don't want to leave my answer as a mixed number. So you say the whole number times the denominator. 4 times 10. And then you're going to add the numerator. Add 9. So 4 times 10 is 40, plus 9 is 49. This will be your new numerator. And the denominator stays the same. So my denominator was 10, it's still 10. 49 over 10. All right. Converting repeating decimals to fractions. So we did non-repeating decimals that were terminating, and now we have repeating decimals. Big number 3, for every digit that repeats, there will be a 9 in the denominator. For every digit that does not repeat, there will be a 0. So if it repeats, we're going to put a 9 in the bottom. If there's a digit that does not repeat, we're going to put a 0 in the bottom. Big number 4, for decimals that have a repeating and a non-repeating part, the numerator is the entire decimal minus the part that is not repeating. So let's do a couple examples of this. Example number 7. 0.1, and the 1 has the bar over it. So the 1 is repeating. So this number is 0.1111111, and it keeps going forever. So there's one digit under the bar. So we're going to put 19 in the bottom. So I write my whole number in the top. So just ignore the decimal, ignore the bar, write the number in the top. So 1 goes in the top. And there's only one digit under the bar. So there goes 19 in the bottom. 1/9 is reduced to lowest terms. So this is your answer. And you can check yourself by typing in your calculator 1 divided by 9, and you should see 0.11111, and it'll fill the screen up. Example number 8. 34 hundredths is repeating. So again, ignore the decimal and the bar. Write 34 in the top. There are 2 digits underneath the bar, so we put 2 9s in the bottom. 34 over 99. Now let's check to see, can we reduce this? So 34 divided by 99, type in your calculator, hit math, and then enter twice. And this one does not reduce either. So that's your answer. Example number 9, 815 thousandths, and this 8, 1, and 5 are all under the bar, so they're all repeating. Write the whole number part in the top, and then put 9s in the bottom for each digit that's under the bar. There are 3 digits under the bar, so 3 9s in the bottom. Check to see if it reduces. And this one does not either. So that's your final answer. Now, examples 10 and 11 and 12 have part that are repeating and part that are not repeating. So just the 4 is under the bar, not the 2. So what you do on this one is you have to subtract. So to find out what your numerator is going to be, off to the side, you're going to say the whole part would be 24, and you're going to subtract the part that's not under the bar. So the 2 is not under the bar. So 24 minus 2 gives me 22, and 22 is my numerator. So the whole part minus the part that's not repeating. Now, for each digit that is under the bar, you put a 9. So there's one digit under the bar, just the 4. And now we're going to put a 0 for each digit that is not repeating. The 2 is not repeating, So put a 0 for the 2. 22 over 90 can reduce to 11 over 45. So this would be your final answer. If you type in 11 divided by 45 in your calculator, you should get 0.2 and then a bunch of 4s. The 4s will repeat. Example number 11. 391 thousandths, where the 9 and the 1 are both repeating. So again, off to the side, 391 is the whole part. Subtract the part that's not repeating, so subtract the 3, and you get 388. So this would go in the numerator, 388 over. Now in the bottom, there are 2 digits under the bar, so 2 9s go in the bottom. 1 digit is not repeating, so put a 0 for that 1 digit. So only 1 0 because only one number is not repeating. 388 over 990 can reduce to 194 over 495. Again, remember to make sure that you put your answer in lowest form. All right, number 12, example 12 has a whole number part, and then we have non-repeating and repeating decimal parts. So we're just going to ignore the 2 for a moment. We'll deal with that at the end. So 709, and we're going to subtract the part that's not repeating. 2 of these digits are not repeating. The 70 is not repeating. So 709 minus 70 gives us 639. That will be the numerator, 639. In the denominator, I put a 9 for the 1 digit that's repeating, and then 2 digits are not repeating, so put 2 zeros. 639 over 900. All right. Now this 2 is still a whole number, so it's 2 and 639 over 900. We're going to convert this to an improper fraction, so we say 900 times 2 plus the numerator plus 639 gives us 2439 over 900. Okay, and we can type this in, hit math, enter, and it reduces to 271 over 100. And that would be your final answer.